Okay, cool. All right. My name is Elliott Grabill. I teach math. This summer, I taught algebra to a bunch of Baltimore City high school students. Many were grade levels behind. They hated math. They weren't motivated to learn math. And what I was teaching was already stuff that they had already been taught year after year in high school, middle school, etc. And so one day, a young lady, a student of mine, raised her hand and she said, "Mr. Grabill, when am I ever going to need this in real life?" Now, I've been teaching math for almost 10 years now. There's never been a year when someone hasn't asked me that question. And, you know, what if going out and getting a lucrative career in STEM was not this young lady's cup of tea? What if she wanted to be a poet, or a philosopher, an artist, or an activist, or something that doesn't necessarily lead to a career but inspires her to think critically and to give back to society in a way that we desperately need? At this point, I had read enough books and I'd done enough research that I know that standardized testing undermines minorities and socioeconomically disenfranchised people. So I said, I'm done with schooling them with this sort of Eurocentric style of math curriculum. I believe, first and foremost, that if a student's going to take my class, they should walk out at the end of semester with a sense of numeracy, an appreciation of mathematical logic, and a motivation to want to learn more. And I came up with a multicultural math curriculum that shows not just how mathematical ideas are shared amongst Western cultures, but also how all cultures have used their own mathematics to solve their own sorts of problems. So here are some ideas for you to ponder. The quality of life among the Mayans in the 9th century was comparable, if not better, than the civilizations on the other side of the Atlantic. They had a base 20 number system. Now, I think that deciphering this number system would be a good launching pad for teaching polynomials in an algebra class like Math 111, which is what I teach, or even in high school. It should also just reinforce people's multiplication tables. Here's a more higher level math problem. This is the Warlpiri. There are people from Australia. They're small people, so they have to be very mindful about who to marry whom. We don't want to get married to like a second cousin or something. So they developed this very complex but logical system of who to marry whom based on group theory. The Incans had no writing system. They didn't even really have a written number system, but they had these bundles of strings called quipus, which carried numeric information, a lot like modern graphs, like statistics today. And these methods led them to more efficient farming, stone architecture, and an organized economy. And like many cultures, Incan pottery and textiles and art were geometric, using reflections, rotations, translations, and glide reflections, 3 out of 4 of which I teach in Math 111. This is kind of my favorite, the Chokwe's of sub-Saharan Africa. They created designs called Sona, which, or singular would be Lusona. And this one right here, this is actually, it tells a story. All of these tell stories. This is their creation myth. This is a story called Sambalu the Rabbit, and it's basically a David and Goliath story. The center represents a salt mine that all of the animals are trying to get, and there are lions and hyenas, and then there's this rabbit that's smaller and more defenseless than all the other animals, but he's clever. And so he is able to get to the salt mine, and there's the rabbit. And of all of the dots in this picture, this is the only dot that makes it to the rabbit. And the moral of the story is, of course, you don't have to be strong to win, you just have to be clever. And the only way that we can really explain how this moral is by looking at the mathematical properties, seeing how this is the only dot that gets there. So in conclusion, I think ethnomathematics can make a math curricula less dry and more culturally inclusive. And I'll leave you with this question. If math is really about discovering, is math really about discovering absolute truths like the Pythagorean theorem? Or is math about serving social function, problem-solving practice, and an expression of culture, its values that vary from culture to culture, necessities and aesthetics? Thank you.